Welcome, it's Miss Skelton here, and this is one of your very last videos of the year. And we're going to talk about how to solve exponential equations today. So just to give you kind of heads up, since we're really close to the end of the year, we're only going to cover one topic this week that's new, and only one next week. So 2 topics left before the year ends. And the goal is that if you need to catch up in this class or in any other class, only doing one topic per week will give you some time to make that happen. Okay, so let's get into our new topic for today. So we have exponential equations. What we're going to see today is potentially exponential, a base and an exponent on both sides of the equation. And our goal is to figure out what x needs to be to make the equation true. I went ahead and wrote out the steps we're going to use today. So we are going to use a common base to solve all of these problems. So common base means we're going to be looking at the base in the problem, the base that has the exponent, and it has to be the same base on both sides. So we're starting off with an easy one. If the base isn't the same on both sides, we're going to have to rewrite the problem so that it does have a common base. And then the part that's actually pretty fun is then we take the exponents and set them equal to each other, and it'll be like solving an Algebra 1 problem. Okay, so let's look at this first one. The bases are the same. So if I wanted this left side to equal the right side, I would just need for the exponents to equal each other. And then all I'd have to do is solve a normal equation from here. So I'd add this x to cancel it. 3x equals 12. So x is 4. So they had a common base of 3, so I just had to make the exponents equal. Then you can still check and make sure you did it right. So if you go to your calculator, on the left side I would have 3 to the 2 times 4 power, or 3 to the 8th. And then on the right side, 3 to the 12 minus 4. Oops, better use subtraction. 12 minus 4 is 8, so I should get the same number. So these problems are capable, or you're able to check them, is what I'm trying to say. Okay, so let's try one that doesn't have a common base to start. So our next example is 27 to the 4x minus 1 power equals 9 to the 3x plus 8 power. So we are going to have to decide what small common base could be used to create both of these numbers. Meaning, what small base could I raise to a power to get 27, and could I raise to a different power to get 9? And here you may have noticed that there's a common base note card, which is this. I know it looks kind of overwhelming, but these are all of our common bases that we're going to be sticking with, pretty much 2 through 10. Some will come up more often than others. And then what I did is I raised those bases to certain exponents. So what this means, if we look at the base of 2, 2 to the first is 2. 2 squared, that could become a 4. 2 to the third could become 8. 2 to the fourth could be 16. So if I see 2, 4, 8, 16, 32, or 64 come up in my problem, well then I could use a common base of 2. Our problem has 27 and 9, so I want to look and see what base does that come from. I find 9 and 27 both come from a base of 3. So that's the common base that we are going to use in this problem. And then you'd want to scan the card to make sure they don't come up anywhere else either. Like 9 comes up with 9, but I can't make 27 by raising 9 to a power. So I'm going to keep pulling this out every time we do a problem, and it's available for you on Canvas if it's helpful to you. So when the common base is 3, I need to think of 3 to what power makes 27? And the card will tell you that too. 3 to the third makes 27. So instead of writing 27, I'm going to write 3 to the third. I'm allowed to do that because it's the same as 27. The exponent doesn't change. On the right side, I have to think about common base of 3. What power do I need to make 9? You probably know, but 3 squared is 9. So I'm going to rewrite the 9 as 3 squared. And then the only thing that changes in our work is now we have new exponents. So this 3 that I made an exponent is going to actually have to distribute to the 4x minus 1 that was in the exponent before. And the 2 that I used as my exponent on my common base is going to distribute to the 3x plus 8 that was our original exponent. Now I have an algebra 1 equation left to solve. So I'm going to go ahead and distribute the 3, making it 12x minus 3 equals 6x plus 16. I'm going to subtract the 6x on both sides. So 6x minus 3 equals 16. I'll add the 3, so 6x equals 19. And then I'm going to divide by 6. I want you to leave your answer as a reduced fraction. Decimals are fine too, but most of the answer choices are going to be in reduced fraction form. So 19 over 6 can't reduce, and that's my final answer. We are going to have a lot of answers that are fractions or decimals, so don't let that freak you out. Okay, we're going to do a lot of examples over this. So if that first one was confusing, no fear, we're not close to done. Okay, the next problem that we're going to work through is 4 to the 2x minus 5 power equals 64 to the 3x power. So our first goal is to figure out what common base, what smaller number do these both come from that we can use. So usually I look at the smaller one and I see if it could be the common base. So if I look at 4, okay, 4 comes from 4 obviously, and 64 also comes from 4. So I'm going to go ahead and use 4. Now some of you might have been like, well, couldn't I use 2? Because 4 and 64 also come from 2. And you can. It's definitely possible you'll get the exact same answer if you do. It's just a little easier if you pick the bigger base in the problem. But if we get to another one like it, we'll choose the other base and you'll see that it works the same way. Okay, so I'm going to use 4. So the left side already has a 4. That's awesome. I don't have to change it. Now on the right side, I need to rewrite this so that it's 4 to some power. It has to be the same as 64. So my handy dandy note card says 4 to the third power is 64. So I'm going to make that 4 to the third. And the 3x is still there. Now that they have the same base, we're just going to focus on, hey, what's left in the exponents and set them equal to each other. And this 3 is going to multiply by the 3x that we started with. So 2x minus 5 is equal to 9x. I'm going to subtract 2x. Negative 5 equals 7x. And then I'll divide by 7 to get x equals negative 5/7. Again, that fraction is fine. Leave it as a fraction, no need for a decimal. Okay, let's try another one. How about we do one that has a fraction, your favorite. Okay, I feel like this color is a little harder to see, so let me switch to something darker. So let's do 36 to the 5x plus 2 power equals 1/6 to the 11 minus x power. So we need to figure out what common base we can use. So looking at my note card, I have 36. Okay, well that comes from 6. 6 squared makes 36. Now the part we need to talk about is if I want to make a fraction, hopefully you remember from the past couple of weeks, negative exponents make a number flip and make it into a fraction. So on the left side, well, we're going to use 6. And on the left side, it's easy to rewrite because I can make it 6 squared. 6 squared is definitely 36. The 5x plus 2 is still there. On the right side, I need the 6 to become a fraction. So I need a negative exponent. Since it's staying as a 6, it would just need the negative first power. Now, if you want to make sure that you're right because you don't feel confident, then in your calculator, 6 to the negative first power, crazy decimal, math, enter, enter, that's the same as 1/6. So you can make sure that you're right before you go any further in the problem. The 11 minus x is still there. And now we're going to solve the equation that is in the exponents. So I'm going to go ahead and distribute as I rewrite this problem. So 2 times 5x, 10x, 2 times 2, 10x plus 4 on the left side equals negative 11, and the negative 1 times negative x would make a positive x on the right side. Now let's solve this equation. I'm going to subtract x so that my x's are on one side. And hopefully once you get to this step, you're feeling confident because you're just using your solving equation skills. Oops. Alright, so I have 9x equals negative 15. I'm going to divide by 9, so negative 15 over 9. And I do want you to check and see if it can be reduced. 15 and 9 can be divided by 3. Leaving me negative 5/3. Awesome. Okay, let's do a few more. Not really going to make them trickier in any way. I'm just going to keep going over the same steps. So hopefully it seems easier to you. Alright, let's see if we can fit another one on this page. 10 to the 3x minus 10 equals 1 over 100 to the 6x minus 1. Okay, hopefully the common base is kind of standing out to you. So I have a 10, I have 1 over 100. Oops. So I do see that both of those come from 10. So if one side already has that base, then don't change it. Just rewrite it. Now on the right side, I'm going to write a 10. I know that I need it to become a fraction, so I need a negative exponent. And then ask yourself, how does 10 turn into 100? 10 squared is 100. So we need the negative second power, And remember, we're allowed to do this because 10 to the negative second is just another way to write 1 over 100. We didn't change the number, we just changed the way it's written. Okay, now let's solve the equation in the exponents. So I have 3 minus 10 equals, I'm going to go ahead and distribute my negative 2. So negative 12x plus 2. I'm going to choose to cancel the 12x. So I get 15x minus 10 equals 2. Add the 10. 15x equals 12. Divide by 15. And then I'm going to reduce that for my final answer. So 12 and 15, let's divide them both by 3 to get 4/5. Awesome. Okay, let's go ahead and do maybe 2 more. So next problem. Let's try 1 over 729. Okay, so immediately I know I'm going to need a negative exponent to make this fraction here. The exponent it currently has is 2x minus 6 equals 81 to the 3x minus 5 power. So I need to know what 729 and what 81 come from. So we have a couple of choices. We could use 3 and make it 3 to the 4th for 81, 3 to the negative 6th for 729, or the 1 over 729. Or we have 9 that we can do 81 and 729 with, just by using a square and a cube. I'm going to go ahead and use 9 as my common base. So since 9 cubed is 729, I'm going to rewrite this as 9 to the negative 3rd, so that I'll see the 729 as a fraction. On the right side, 81 comes from 9 squared. And then we want to solve the equation in the exponents. So I'm going to distribute the negative 3 as I rewrite this. 6x minus 10 on the right side. I'm going to choose to cancel the negative 6x. 18 equals 12x minus 10. When I add the 10, I get 28 equals 12x. And then I'm going to divide by 12. And let's go ahead and reduce that. 28 and 12 are both divisible by 4, so I have 7/3 as my final answer. Oh, I guess I didn't write. The common base we chose to use was 9. Okay, let's do one more. Another one that has a choice of common base, and I'll pick the smaller one this time. So let's do 64 to the 2x plus 4 power equals 16 to 5x minus 10 power. So you'll see these come up 2 times on the note card. You'll see 16 and 64 could both come from a common base of 4. But I said let's go ahead and see what happens if you pick the small base. So here 16 and 64 could also come from 2. I'm going to choose 2 as my common base. Okay, so the 64, I would need to take 2 and raise it to the 6th power to make 64. The 16 is from 2 to the 4th, so I'm going to rewrite that as 2 to the 4th. And then let's solve the equation in the exponents. So the 6 will distribute, making 12x plus 24. The 4 distributes to make 20x minus 40. And then let's solve. I'm going to subtract my 12x. So 24 equals 8x minus 40. When I add 40, I get 64 equals 8x. And when I divide by 8, I get 8. If you compare this video to the notes that are on Canvas, the ones that are already complete, you'll see this exact example worked with a base of 4 instead, and you end up getting the same answer. Or I guess I can show you right now. So no matter if we used the 4, we would still get 8, or if we went ahead and did 2. I'm hoping this video is helpful. Please email your teacher or Zoom with your teacher if you have any questions at all. Y'all are doing a great job, and we're so close to the end. We can do this.